technical difficulties on the presentation mode from a perspective of the connection and the colors, so just bear with us. As soon as he comes back with the proper cabling, we'll be able to get to the color going. But I thought I'll start and go ahead and talk to specifically cloud workload security and the 6 critical criteria that we believe are important when you deploy in a cloud environment. Right? So Cloud Passage, who we are a startup based out of the San Francisco Bay Area, cloud infrastructure, security and compliance focused company. We have about 150 customers, enterprise customers today. About a large number of them in the Fortune 500. And what we're seeing is a huge transformation from perspective of delivery of IT and security using newer methods like DevOps, right? And those methods are not controlled by IT. They're controlled by your business. It goes into agility, DevOps method, orchestration types of things that happen. And with that come a huge amount of challenges related to software-defined data centers, challenges related to how you deliver new applications, orchestration tools. And the existing environments you have today with your security controls and security tools do not necessarily transfer into a cloud-based infrastructure that easily. Just because they have certain cloud-based appliances doesn't mean they transfer into the cloud that easily. And security and compliance tools have the biggest challenge related to cloud transformations, and that's what's going on today. So, moving on, cloud-based security, and I think this is a slide that marketing created to be funny, so I guess it's funny, but let me move on. So, what's happening today from a data center perspective, existing data center perspective, is that you're living in a isolated infrastructure type environment focused on your perimeter network-centric tools, right? You have your own applications, virtualized applications, virtualized infrastructure, or hardware bare metal-based infrastructure. And you have application A, B, C, D, and such in your infrastructure behind your firewall, protected by your tools and in an approach internal to your data center, right? So moving on, go ahead. So moving on, what we're seeing when you have this kind of infrastructure, that's better. Yeah, that's fine. Thank you. So moving from that internal data center you have, with those applications you control, with the infrastructure you control, with the perimeter and network-centric approach you control, and with the appliances you have today, you secure it through your firewall, 40 gig firewall appliance, your IDS IPSs, your web application firewalls, and protecting these applications with the traditional data center environment is what you've been doing today. And then from there we moved on to utility computing, right? This is where your internal cloud-based applications started internally in your virtualized infrastructure. People moving more towards a utility model that brought levels of efficiencies you didn't have before. This is using things like self-provisioning in a UCS direct type environment, VMware vCloud, building your OpenStack infrastructure. Now those applications that were around within the data center behind the firewall moved to shared hosted environment, shared application environment, right? And now the applications are running within your firewall, behind your firewall, within your infrastructure, internally to you, right? So we pull this slide out. So it's still a private hosting model, and you are behind the firewall, and you built that infrastructure internally. And now what you're trying to do is to move, as compute demands increase in this utility model, to get some efficiencies from moving to the cloud. So that's what you're seeing on the right-hand side. So you now want to move some infrastructure to the cloud because you see the efficiency, agility, and moving to the cloud from that internally hosted, internally provisioned environment. So you go ahead and build a VPC. You still have the perimeter. You build a VPC, a virtual private cloud in Amazon or Azure or Google Compute or any of the environments. They just don't like me today, so all the challenges. But so you're building that, and then folks said, hey, we want to be secure, so we're going to go ahead and do VPN, a virtual private network, to that VPC, right? So what you want to do is use that existing perimeter you have already built, spending millions of dollars, and network-centric tools, and security tools, and firewalls. You're trying to backhaul all that virtual private cloud information through your traditional perimeter. So this is called tromboning. It's a kind of an industry term that's used. And you're backhauling all your network traffic through your existing security tools. That's what you're used to, right? This becomes a huge latency issue, right? A huge issue from a bandwidth perspective and availability perspective. And it creates a lot of issues for deploying applications with the agility and speed you're required to do. So the next approach was to find visibility into that infrastructure that's running in the cloud, which you don't get with this approach either. So the next step was to move all those security appliances you have in a hardware form factor into a virtualized form factor into the cloud environment. The problem there is this particular hardware, with hardware acceleration, with high-density chips like ASIC chips, they were built specifically to those applications to do security in those specific hardware. They don't move very easily to an Amazon AMI and provide the same kind of efficiencies you're looking for. It becomes very expensive to run in a cloud computing model. So that doesn't help you as far as securing and providing visibility and providing the controls you want in your cloud-based infrastructure. So what we are proposing is that when you move to a cloud-based architecture, whether it's a private cloud, public cloud, a hybrid environment, virtualized infrastructure using utility computing internally, what you must do are 6 things. And what those things are is, 1, the security must be at the workload level, right? Which means that the security must be at the compute level, where you're computing within your infrastructure and going to the cloud, right? Whether it's the internal based virtualized hardware you have in your infrastructure, or moving to a cloud-based environment or a hybrid environment. The next thing is you need to cover a broad set of controls, whether they be security or compliance. So, and we'll talk to those individually in a bit here. The more important aspect of moving to the cloud and providing the agility and the speed and the deployment capacity you want in the cloud environment is the orchestration aspect. And this is an area that you're going to hear more and more as companies move to what we call mode 2 of IT, moving from the existing infrastructure to a cloud-based infrastructure. Automation, DevOps becomes extremely important, and you're going to hear these terms again and again as you move there. The other aspect is, as you move your infrastructure to the cloud infrastructure, you still want to be able to mind the gap between the two infrastructures, right? You go from your internal data center-based infrastructure into a cloudy environment. You want to be able to, your tools to work, or the platform you're using to work with those internal infrastructure you have with security and controls and compliance, as well as a cloud environment. And scaling vertically and horizontally. The ability to go not only scale up in a cloud infrastructure. In fact, in the cloud model, you want to be able to scale down. Most of these security tools have a great amount of difficulty that are existing today scaling down, because they have built up this huge, hardware that's high density and very focused on large amount of capacity. They can't scale down to a microservice like a Docker-based container running on a cloud server. And then horizontally to scale to thousands of servers and hundreds of thousands of containers as you move into a containerized architecture. The reality of IT today, in any enterprise, unless you're a brand new startup, is that you're going to have a combination of existing tools, existing infrastructure, and some moving to the cloud using automation. So you need to gap these two together, and the platform needs to support that while it secure the workloads, right? So individually, if you look at security at the workload, what does that mean? It's like, somebody asks, why do you rob the bank? Because that's where the money is, right? So same goes here. This is where the compute is happening, right? It's not a monolithic server. It's happening at a compute level in a cloud-based architecture, whether it's a container, a microservice, a server that you spun up in Amazon or Azure or Google Compute, or even your internal utility computing infrastructure. It's a layer of abstraction. It has no specific network boundary. It doesn't have any perimeter, hypervisor. Nothing's connected. It's always abstracted out of that. It's a workload. It's a compute instance. And then moving on, it needs to be a policy-driven, because you need to apply, as you compute, as you scale and burst into the cloud infrastructure, you need to apply your security and controls to that. So you need to be policy-driven and logically grouped. What we mean by that is your firewall has dissolved, your network-centric approach has dissolved from a perimeter perspective. You need to be able to logically group these workloads or containers or any type of server infrastructure you're moving to the cloud in a way that makes sense for your separation of duties, your compliance requirements, and security requirements, right? And then be able to apply it automatically into your infrastructure, right? So those are critical aspects of what you want to do. Of course, portability, scalability, all the good words around transparency and universality when you deploy to a cloud infrastructure. So these are critical aspects of when you want to do security at the workload. It's a different way of thinking because you're so used to getting your network appliances, getting your firewalls, perimeter security appliances, and deploying infrastructure that you can touch. But when you can't touch the infrastructure, when you're moving to an environment that's bursting, thousands of servers every other day or every month or whatever, however you want to deploy it in an automated fashion, the workload-specific compute, workload-specific security, and controls and compliance becomes very important. So when we talk about security at the workload, what we mean by that is the operating infrastructure that you run on, the operating environment, whether it be Linux or Windows or other operating infrastructure you run on, and mostly it's Linux and Windows. And then the application stack itself. So a compute instance, or what we call a workload, doesn't just happen just because you spun up an Ubuntu instance or AMI Linux instance in Amazon. It happens because you have a specific work activity that happens through an application. So both of those is considered a workload. So broad set of controls. This is nothing new. This is like the basic important blocking and tackling you do today every day, right? Visibility and awareness into your infrastructure. You had that. You had all the control you need in your internal data center. But you're losing some of that when the perimeter dissolves and the network model dissolves you have internally and the segmentation dissolves. You want strong access control, multi-factor authentication type of access control into your cloud infrastructure. Extremely important. As you move on, vulnerability management, right? The ability to do an on-demand scan, whether through a GUI or through an API, hugely powerful. 99% of most of the breaches recently in the past year have been through known vulnerabilities that were reported as a CVE within weeks or months. So the bad guys, however sophisticated you think they are, they're using basic vulnerabilities in your existing infrastructure. And it's nothing more, nothing less. They're using and hacking into what you haven't patched essentially in your infrastructure. So basic blocking and tackling is important. Data protection, data at rest, data in transit, extremely important. Compromise management, essentially looking at any type of malicious activity, indicators of compromise, and taking necessary remediation action is important. So all these things I talked to, none of these things new. It's what you do today and what you have in your existing policies and security controls. What's important is the automation aspect of it. So when you deploy this through rapid deployment technologies or agile IT, DevOps, rugged DevOps, orchestrate that deployment through API calls, RESTful API calls, that's what gets all this stuff into a cloudy environment with the controls, the broad set of controls you're looking for, right? That's what's important. So what are those broad set of controls? It could be, as I talked to, software vulnerability, configuration security management. Very important, you're going to make sure that your server instances you configure into a cloud environment, wherever it runs, has the necessary configuration settings that are hardened configuration settings according to NIST, CIS, or even things like DISA, which is the government standard for internal Department of Defense controls for server security and application security. Traffic discovery, you want to check for east-west traffic, ingress-egress points in your infrastructure when you deploy in the cloud. Even if the cloud instance stays there for a few hours, an ephemeral instance like a Docker container, you want to make sure you discover the traffic, keep it logged to look for those anomalous activities, look for compromises in the infrastructure. Traffic tied to your applications, internal processes, port numbers, and users is very important to understand. That's an east-west traffic perspective. Firewall management orchestration, the entire microsegmentation conversation around these ephemeral instances is very important. The ability to provide separation of duties when you don't have that perimeter firewall in a workload or compute instance that changes constantly from internal environment to external environment, going from different providers and such. Managing accounts on server, making sure the privileges are in place, and you provide server security from an account management perspective. Multi-factor authentication, detecting intrusions through logging, finding anomalous activities in your infrastructure. File integrity monitoring, checking your operating infrastructure files, kernel files, your registry. Again, a combination of these controls is what provides that security and compliance you're looking for. So this I talk to as I consider to be the most important aspect of what we do from a workload security perspective, and different level of thinking from what you're used to in the traditional mode 1 of IT, which is IT controlled deployment scenarios. So I'll get to that in a bit. So automated, orchestrated, right? What that means is that today, when you provision an AMI in Amazon, when you provision thousands of containers on a Docker server, the DevOps folks, it's a culture as well as a operational deployment methodology. They just want to be bothered by the security folks for control, right? They just want to deploy as many releases as they can. And that deployment brings challenges to the security folks and compliance folks who always want control. So there's a constant challenge, a chasing of the DevOps release cycle from the security folks and the compliance folks to understand how we can secure this instance you're releasing, how we can secure this instance, provide compliance to this instance you're releasing, right? So that's the question we come across. But how do you solve this problem? What we need to do is provide a policy-driven, orchestrated, using DevOps methods within the tools they use, like Chef and Puppet and Jenkins-type continuous integration, provide that security at the moment of provisioning, right? So when you deploy your gold image and you want to spin up thousands of servers out there, what you want to do is the ability to apply those security policies, the server hardening policies, the file integrity policies, at the moment of deployment, at the moment of provisioning. So then it becomes security and DevOps working together, security and compliance and DevOps working together, and it becomes a DevSecOps story or SecDevOps story. And you're going to hear those terms more and more as we progress through this cycle of moving from the traditional IT to more DevOps-focused delivery methods. So, moving forward, continuing that conversation. So it used to be in mode 1 of IT, you had a situation where IT controlled its deployment cycle. The releases were maybe 1 or 2 per year. Traditional waterfall-based methodologies were used, and it had a system analysis and deployment cycle. Everybody knows this traditional deployment cycle. But what's happening today is that you're getting a release cycle done every month. And that's some companies, one of the big customers of Cloud Passage is Netflix. It's a poster child not only for Amazon, because they have thousands of workloads running on Amazon. They bring them up and down every day, but also for DevOps. So when you combine all these kind of release cycles that happen very frequently, this becomes very challenging to deploy security, right? So this is where the DevSecOps story comes into play. And more importantly, when you iterate those cycles through multiple dev teams, you have multiple releases every month. Internally at Cloud Passage, we release about every 6 weeks. We have a new incremental release coming up. We are a DevOps shop ourselves. And the methodologies and the kind of deployment cycle is very different from what you use traditionally. So what you need to do is deploy it with that core security controls and policy in place as you deploy and provision your instances, whether they be in the private cloud infrastructure using utility computing, public or hybrid type environment, right? You want to do your code testing, unit testing, all those things can be done when you deploy that at that compute level with multiple delivery cycles. And all this information you're collecting from microsegmentation to ingress traffic as you deploy in your cloud infrastructure need to be fed into internal reporting dashboards, whether it's GRC for compliance, SIM for continuous monitoring, and internal tools need to know those things. So you'd have a RESTful API that sends that information directly to your existing infrastructure. So what does that mean? So the platform that supports this type of cloud infrastructure needs to support not only the cloud-based deployments, but internal data center-based deployments, right? So you're looking at supporting your data center hosted servers today. They could be bare metal, they could be virtualized. Supporting a colo facility that controls just the physical infrastructure you run. And then moving on to multiple public providers of infrastructure, whether it be Amazon today, Azure tomorrow, or Google Compute, IBM Software, Rackspace, whoever you run, right? Depending on where you run it, you need to be able to provide that security controls and compliance controls across this pool of delivery, right? Whether you're using internal or external, and again, bridge the gap between two types of infrastructures with a single platform, a single pane of glass, of security control and compliance control. Scale vertically and horizontally. I think this is an extremely important aspect of what a cloud infrastructure would look like, right? This is a situation where internally in your infrastructure today, bare metal servers, 64 core, 128 gig of memory or 256 gig of memory, and asking for an instance, a virtual instance with 200 megabytes of memory in that type of infrastructure is not a big deal because you have a lot of compute. But when you go to the cloud, and for example in Amazon, a micro instance or a nano instance, which is even a smaller level of compute, you can't ask for that type of compute power in those instances. It could be 10 meg or 2 meg, right? So, what is 100 systems when you ask for compute from a local a data center or a virtualized data center versus thousands of compute instances you're looking for in a cloudy environment, in a public infrastructure? It could be tens of thousands or 60,000. If you go to microservices, you're looking at hundreds of thousands of containers that are ephemeral that go away every half an hour or every half a day. So we're moving away from the monolithic, kind of the Soviet Union type factory that built everything to a smallest level of compute. The world is moving away from this big compute instance into small and smaller compute instances. So if you looked at in the past, the bare metal servers in your data center, they would have taken about several minutes to boot up. If you look at a virtualized instance, you're looking at about a minute of time to boot up. If you look at containers or microservices, we're looking at about milliseconds of boot up time, right? They're instantly up as you run it because they have a stripped down version of the kernel, and also they're running a single process. So you need to be able to support visibility, the microsegmentation, the controls from security perspective into that smallest level of compute when you move to the cloud, right? Whether it's going from a large service you deploy or microservices you deploy to containers. So the platform has to support this level, the smallest level as opposed to the biggest level. So scalability is moving down, and most of the existing tools today are unable to support at that level of compute the security and control you're looking for. That's fundamentally the challenge of moving existing perimeter network-oriented tools into the cloud, because they're never designed for a microservice, never designed for a nano instance of compute. And that's what the DevOps teams are using to deploy, to find the agility, find the speed, efficiencies they're looking for from a cloud-based deployment. So the reality of IT, it's not greenfield. That'll be fantastic if it's a greenfield reality, right? So we can easily do what, destroy the trees and build some new factories out there. But that's not the reality we're looking at, right? Reality is this, which is thousands of existing infrastructure and some that might move to the cloud, some might move as is into that greenfield opportunity we're looking at here. So we need to be able to deal with this reality with a platform that supports both ends of the story. Because nobody is either to the right, unless you're a brand new startup which has no infrastructure and no VC or will give you money to buy infrastructure today. They say go to the cloud, because that's where everybody's starting a company today. But the enterprise that are existing today, 100% not in the existing infrastructure, maybe not 100% on the greenfield infrastructure, but you're in a combination of both. So let me try to explain this one. This is something that Gartner talks to mode 1 of IT and mode 2 of IT. So mode 1 of IT is the traditional marathon runner, right? You're using existing technologies, waterfall methods, and you're releasing applications every, couple of times a year. And you have a very long cadence-oriented meetings, and you have traditional software analysis going on before you deploy the product. And those applications are getting deployed today, but less and less as time moves on. The green slide here, the green mode we talk about, or mode 2 of IT, we're looking at a sprinter. So business is demanding the agility, the speed you're looking for, and folks are moving maybe their internal applications, initial applications, low-risk applications into that DevOps-based cycle we talked about before. But as you move on, companies are somewhere here, right? So as you move on, that deployment cycle accelerates, and eventually, all organizations will move towards the DevOps-based cycle. Don't know when that'll happen, but they'll have more applications on mode 2 of IT, the sprinting methodology of deployment, because of the competition that you're going to face from other businesses that are deploying in an agile way. And then there's going to be something in between. So the tools you support, the platform you choose for security controls and compliance that move to the cloud need to support both modes, right? That's important. So reality of IT today, virtualized infrastructure, bare metal servers. Maybe internally you have internal provisioning in a utility compute model internally. We have some customers who do that. Internal provision, they have nothing in the cloud. They may be using containers internally for testing purposes or delivery purposes of internal applications. They may be using DevOps tools like Chef and Puppet and Jenkins type continuous integration. They may be using vCloud infrastructure. But then you may be moving to the cloud. You're testing certain applications in the cloud because of the kind of operational efficiency you're going to get. The business will demand that you move to the cloud because of the savings you get from running on-demand compute. And this is where the challenge comes. So the reality of IT is something that the tool you choose or the platform you choose for security controls and compliance needs to support. So we covered 6 things. Working at the workload, a broad set of controls we talked to, and continues to add to that. Automation, DevOps, RESTful APIs, continuous integration type tools. Works anywhere in any infrastructure, at any scale. And I talked about how the scale needs to go down. The smallest compute level is what's more important than the highest compute level. And we talked to reality of IT, mode 1 of IT, working with mode 2, and you need to be able to bridge the gap with a tool and a platform that supports both. So we have issues around these deployments, finding security and control, and you want to move from chaos to a platform that's orchestrated, that provides the kind of security and controls you're looking for, and the integration points you need through a RESTful API in real time or near real time to the existing tools and technologies you have. So, we have time for questions? Or? Okay. If you have any questions, I'll be happy to answer those right now. Does it make any sense? Okay. Thank you very much.